Welcome, everyone, and thank you for joining us today for the Healthcare IT News webinar, Traditional MPIs Are Dead. What's Next? It's being sponsored by Verato. My name is Gus Venditto, and I'm the Vice President for Content Development at HIMSS Media. I'm the moderator today. We look forward to your questions, which we encourage you to enter into the question box you see on your screen. They'll queue up during the presentation, and after the presentation, we'll make every effort to get to everyone's questions. Master Patient Indexes, or MPIs, and Enterprise MPIs, also called eMPIs, aren't cutting it anymore. The healthcare industry is long overdue for an MPI built from the ground up to solve its most pressing patient identity challenges. And it's long overdue for an MPI built to enable true identity interoperability between an enterprise's diverse array of EHR, revenue cycle, and other IT systems. Our speakers for today's webinar are Mark Lareau and Joaquim Neto. Mark is the CEO at Verato, and Joaquim is the Vice President of Healthcare at Verato. With that, I'll turn it over to Joaquim to begin the presentation.
Great, thanks, Gus. And thanks to everyone on the webinar today for coming to discuss the next big thing in MPI data management, specifically Master Patient Index. Looks like we have got a really good crowd here today, over 400 people registered from a variety of different organizations across the healthcare ecosystem, just reinforcing how important a topic Master Patient Index and patient identity resolution is to today's healthcare climate. So today I'll kick things off, and I'll just take about 10 minutes to explain why we're saying that traditional MPIs are dead and exactly what we mean by that. Then Mark will introduce the Universal MPI concept and discuss how it promises to change the way we manage patient identity in healthcare. So let's get right into it. Why do we say that traditional MPI technology is dead? Well, quite simply, there's been very little innovation in this space over the last decade or so. When MPIs, eMPIs were first introduced in the 90s and then into the early 2000s, there was a significant amount of investment in MPI technology. I was a part of that in my past life. As an industry around MPI, we did all sorts of things. We created messaging capabilities to support various HL7 standards. We made significant advancements in matching algorithms, going from deterministic and rules-based algorithms to a variety of probabilistic techniques. We built different types of reports and user interfaces, things to improve HIM and data steward productivity. And we developed quite extensive configurability or customization options into MPIs that would allow them to work in what was becoming increasingly complicated healthcare IT environments. So there's all this activity, but then the innovation just kind of stopped. Some vendors moved their effort into managing other data types besides patients, so mastering provider data or terminology. A lot of effort shifted just generally into analytics and into new types of healthcare applications. But the general notion seemed to be that MPIs had basically gotten as good as they were going to get, and the assumption was that that was good enough. Today we see that actually wasn't the case. So the result is that we ended up in a position where you could put more and more effort using existing MPI technology, and you'd only get modest returns as you continue to try to do better with your patient identity. So the state-of-the-art probabilistic algorithms were capable of doing everything they could. You couldn't improve on the leading Valenti-Sunter record linkage model, for example. You could custom configure, and you could tune your eMPI and maybe eke out some gains in accuracy. You could throw more personnel at the manual stewardship part of the problem, but that also yields just modest benefit. And in many cases, the amount of effort required to improve the performance of MPIs was simply going up because they continued to get more and more complex over the years. So new capabilities were built on top of what now is relatively old technology. So the net result is that MPIs have basically been getting harder to operate and harder to get value out of, not easier, which is what you need them to be for today's initiatives. So the industry is in search of alternatives. We see a lot of signs of this. Right now, there are two industry-sponsored competitions, specifically patient matching challenges that are soliciting innovation in the MPI space. So Chime has one and ONC has one. Folks are probably familiar with one or both of those. Organizations are evaluating a number of different identification technologies or mechanisms, looking for some simpler way to resolve the patient identity problem. Examples of this are biometric devices in the registration process, use of lifetime ID cards or various tokens, maybe on your cell phone. Even the national patient ID is a topic that's been resurfacing lately. So all of this just represents this appetite for the next step in patient identity technology. So the reason we're seeing this activity is that no matter where you fit in your organization's org chart, there are multiple initiatives that increasingly depend on having an accurate and complete view of your patient data. And this is truer today than it ever has been before. Maybe you're working on a CEO-sponsored initiative to manage a series of mergers and acquisitions, trying to compete in a difficult market, or you're pushing the organization to take on risk while providing better outcomes at lower costs. Perhaps you're a CMIO organization and you're trying to use data to improve clinical decision-making in an effort to deliver better coordinated care across a wide ecosystem of provider, personnel, and roles. Or maybe you're in IT or HIM and you're tasked with managing an increasingly large amount of data with a very small staff. In any case, all of these things are reasons why your MPIs ought to be improving to keep up with your needs, and they're just not doing that today. So before I get into talking about why that is, we wanted to just do a quick little poll here. This ties to that last chart we just showed with some of the drivers that we're seeing for people, having this desire to improve their patient identity resolution capabilities and obtain a better view of patients. So if you want to just take just a minute and scroll through here and just check the top 2 or 3 initiatives that are driving your focus on patient identity. We'll give a minute to everyone to check a couple boxes here. They're organized the way the last slide was. So basically each 4 are a group here. So just scroll through those and we'll wait a minute, let people respond, and then take a quick look at the results. All right, looks like we're getting some responses in here. Give it another minute or two for folks to respond. I'm getting some preliminary results here. We're seeing a lot of definitely patient experience is rising at the top. All right, let's see here. Let me see if I can post these to you guys. We're still getting a bunch of responses in. This is great. All right, let me push this out to you guys. All right, so we've done this a couple times before, and actually this is consistent with how we've seen this before. Basically, all these drivers are hit. If you take a few seconds to scroll down, we'll let you just take a look at it and compare it to the answers you gave and see what other folks on this webinar are considering as their most important initiatives. Definitely just the core idea of having a longitudinal patient record that can be used across a number of initiatives is showing up as the highest here. But what we see is that there are just across the organization dependencies on this idea of an accurate, complete patient view, and we're kind of seeing a resurgence in that, or the recognition of that, at least amongst the folks we talk to in the industry. So let's get back to what's kept traditional MPIs from improving and start with the basics. So MPIs use demographic data to match and link patient information. That means things like name, birth dates, address, social security number. That's the basics of it. Now, as you encounter patients in the provider world or the payer world or other parts of the healthcare ecosystem, what happens is you build up this collection of attributes that you know about a person. But those attributes are very often inaccurate or they're just incomplete. So if you've been around MPIs, you've worked firsthand in this space, or if you've been a consumer of EMR data in any way, you understand this sort of underlying data quality issue and how big a challenge that can be towards getting a complete view of your patient data. So you've probably seen various spellings of the same name. You've seen typos in birth dates and social security numbers. You've seen really weird, address formats and more missing data than you can imagine. And these are the types of things that MPIs were built to deal with. And historically, MPIs have done a pretty good job of dealing with these types of what I call data entry errors. However, if you look a little bit deeper, it turns out that a lot of the data quality problems inside of EMRs and other healthcare data generating systems are not problems that are end user created, meaning they're not things that you could train out of registration staff or things you could catch with just the right fuzzy matching technique. They're actually legitimate data scenarios caused by real life events, things like moving. So 18% of the people, up to 18% of the people move every year, and they're going to change their address, or they get married and change their name. Things like that are not data errors. It's just the nature of the underlying data. There are people that have similar names as their relatives, right? You have the same name as your mother or your father. You have siblings that are similarly named, or maybe there's policies in your organization that just prevent you from capturing data, like an SSN. There's nothing you can do to improve your SSN accuracy if you can't capture it. So the number of different types of issues like this that are not kind of traditional data quality issues, that are real world data issues, are out there is a lot bigger than people have realized before. And we think this is actually the biggest limiting factor for current MPI technology to be able to create complete patient views. So the result of this is that in the current state, there's fairly underwhelming quality metrics when you look across the industry. So many organizations have duplicate record rates that are still way too high. They're into double digits, especially when you cross multiple applications in complex healthcare organizations. The financial implications are significant, of course, and then there's a fairly astonishing 86% rate of professionals who know of adverse clinical events that resulted from poor record matching. And this is the one that jumps out at me, and it kind of goes back to that poll, which is the traditional value centered around delivering good patient care. When this large percentage of professionals have seen events, adverse events caused by inaccurate matching, it's still a real problem that hasn't been solved by traditional techniques. So those results, those marginal results come against the backdrop of these traditional MPIs that are fairly old and require too much effort to maintain. So these complex customized implementations, they require significant analysis to make any changes. Dedicated IT staff are required to keep them running. You have to upgrade software. You have to tune things as you bring on new data sources. And then you just have operational staff, data stewards, who have to work full time to resolve all of the issues that get kicked out that can't be automatically resolved. And all of this is just a lot of effort. It's too much effort given the benefits that folks are getting out of the systems. So that's kind of our view on the current state. If you look ahead and you consider the continued shift away from fee-for-service, then really two things happen. So one is the economic impact of fragmented patient records grows significantly as organizations take on more risk, as incentives focus on improved outcomes and reduced costs. It's certain that a complete view of each patient's data will continue getting more important. So from the business side, the issue is getting more important. And then secondly, just the demands for more integration of data is continuing to grow. So the amount of data that you have about your patients that you need to be able to manage is getting larger and larger. So if you have a population health initiative, that's more data you're going to be managing. You have a digital health or telehealth program, that means more data. Consumer applications, again, more data. So with traditional MPIs today, that's inevitably going to mean higher data rates, higher error rates, despite more effort that you're going to put into it from both an IT perspective and a governance perspective. So by now you've kind of got our perspective. We think the conventional approaches are just too hard. MPIs take too long to implement. They're too complex to change, and they're just not keeping up with the demands of today's business and IT climate. So before I hand things off to Mark to talk about Universal MPI and how we think that can change the game here, just think about the generations of MPI technology we've seen. So the first generation of MPI technology was basically a common index that would be used by several applications within a health system, and maybe something that's just embedded in a single EMR. This was the basic capability you needed to operate against patient data. Then enterprise MPIs gained traction, at least for those organizations that had sufficient resources to invest in them. Those systems became complex, and the benefits really haven't been fully realized. And even then, when they are realized, they're just requiring kind of an unsustainable degree of effort. So in the third generation of MPI, what we're expecting is a modern solution, something that enables true identity interoperability within and across organizations, and basically regardless of how big or sophisticated your IT capability is, something that can really help connect the entire ecosystem, because patient data is not living in silos anymore. So we really have to have a solution that is broadly applicable. So with that, Mark, I'll hand it off to you to get into Universal MPI.
Okay, Joaquin, thank you very much. Hello, everybody. This is Mark Leroux, as introduced initially by Gus and then now by Joaquin. I'm going to talk you through the latter part of the presentation, which pretty much answers the questions that Joaquin has set up for us. He's introduced the idea that the market needs a new kind of MPI, which we've phrased Universal MPI. So I've got to answer the question, what is that? And then how is it different than our existing MPI structures? And that's my goal. And I hope it comes clear as I unfold these slides. But in order to do so, let me take a quick step backwards. Maybe not backwards, but let me simplify the problem a little bit so I can build up to the solution for you. We all know that patient matching is hard. It's hard work. It's very complex work, and the software that does it is very complex today. But fundamentally, the equation that determines your matching effectiveness is really quite simple. The data quality, in fact, it's just two factors. The quality of your data combined with the sophistication of your algorithm, those two factors ultimately determine the matching effectiveness. And you know this intuitively. If your data quality is perfect, if all of your identity data, demographic data is perfect, then the matching algorithm that you have to have in place can be extremely simple, right? But the more and more the data quality degrades or is suspect, or different components of it are of lower quality than other components, the more sophisticated the algorithm must be. And so it's a very, very simple equation when you think about it. And when you think about the data and what's going to happen with the data going forward, Joaquin already put forward the thought that 30% of all the demographic data that exists in our patient databases today is either incorrect or out of date for lots of reasons that Joaquin spelled out. The question is, and we've worked really, really hard to try and get it better and better. And you all know this. We go through, yearly data cleansing exercises, or you send the MPI data out to various service bureaus to be cleaned up. Anything we can do to improve the data quality ultimately helps matching effectiveness. But going forward, let's look at what's going on with data. First of all, with the advent of biometrics technologies, I think we can all expect data quality to begin to improve in quality. But with the caveat that biometrics themselves are not the solution. They will certainly improve data quality at the moment of capture, so whenever a patient presents themselves. But it's not going to do anything for all of the existing billions of medical records that are already out there to which biometrics haven't yet been tagged. It's still name, address, date of birth, social security number, MRN that identifies a person. So biometrics will help, but it's not the answer. But on the downside, we have to all recognize the fact that as we put more and more data from different sources into our MPIs, the aggregate data quality has to go down. Like that's a basic truism of data. The more data from different sources that you aggregate into a single database inevitably drags the quality of the aggregate data downward. And there's almost no avoiding that. It's almost like a law of nature or something. By the same token, on the human side of it, the more and more data that we bring into an MPI from different governance domains, different people contributing data, makes the governance coordination problem grow, and it grows geometrically. And again, we all know this intuitively. If you sit in a conference room with 5 people trying to solve a problem, it's manageable. But if there are 10 people or 15 people or 20 people, you get more ideas, but very seldom do you drive to clarity very quickly. And then finally, what's happening with data is that if your strategy for data quality is to improve the data in a golden record at the MPI, and then to ripple backwards upstream through the system, back to the source systems, these corrections that you've discovered at the MPI, the difficulty of rippling corrections upstream gets, as with governance, geometrically more difficult the more data sources that are involved in that process. So ultimately, we're in a situation where we've got 30% of the demographic data being incorrect and out of date. And given the forces that we're looking at going forward, it's highly likely that data quality is going to get worse, not better. And at the same time, as Joaquin mentioned a moment ago, that our current algorithms for doing patient matching, for doing identity matching, have really reached their theoretical limit. The mathematical limit that's described in the basic probabilistic matching has been achieved or reached in the early and mid-2000s. So we really can't expect too much movement there. So what do we do? If today we have an environment that is usable, it's workable, but tomorrow's environment has much more data and more constrained algorithms, ultimately you're talking about less data quality, flat innovation, and ultimately matching is going down, right at a time when Joaquin mentioned that the economic impact and the strategic impact of data matching or patient matching is going up. So what do we have to do? We have to change the equation. We have to do something different. And the basic equation can't change. It's still data times algorithm equals matching effectiveness. But what we need to do is we need to introduce new variables or new components to this equation. What I'm going to suggest to you is that new equation is to apply the newest technologies that we have available to us, which are data or big data technologies. In fact, wrapping all of our patient data into a much bigger construct, which I'll be describing in a little bit as a universal reference database, and then building new algorithms that take advantage of that universal reference database. And this, in essence, what you see here colored in gold is a new formulation of the same problem that we've been struggling with, but it's new enough where it changes the whole premise and changes the whole solution to something which will be usable as we go to the future. So here are the 3 things that a universal MPI would have as part of it. It first and foremost would have a pre-populated reference database. So a database of demographic data spanning the entire potential user population. In this case, it's the entire population of the United States, if we're talking about the U.S. healthcare system. And it would be rich in demographic data, not sparse. It would have a very large amount and very time-dimensioned amount of data about every individual in the country to be used as the universal reference. Secondly, it would have a new kind of matching algorithm that wasn't limited by the mathematical limitations of probabilistic matching, but it could do hypothesis testing. If it thought that a person was matched to another person in the reference database, the matching algorithm could do tests. It could ask questions of itself, like, I think this person that I'm matching is Mark LaRoe, but maybe it's not Mark LaRoe. Maybe it's his wife, Mary LaRoe, because I see there's also a Mary LaRoe in the universal database. What other possible questions could I ask of the database to narrow down my decision here? So that's a whole new way of thinking about matching, where in essence you're hypothesis testing. And the benefits here is not only is it more accurate in essence by having the reference database to work against, but the other really powerful concept of referential matching is that it requires very little to no tuning. It is tuned for sparse data, it's tuned for flush data, it's tuned for old data, it's tuned for newer data. All of that tuning comes part and parcel with having a reference database to go against. And the third and equally important component of the entire Universal MPI idea is that it's cloud-based. It's not premise-based. It doesn't have to be installed in software on servers with people in lab coats taking care of it and upgrades and memory expansions. In fact, it's cloud-based for a couple of reasons. One, the first, most important one is that it can just be plugged into. So it's an API version of the patient matching problem. You can abstract the entire patient resolution problem to an API call. And you should think of this almost as a utility service, such that bringing on new databases to be resolved, with patient identities to be resolved, should be no more complicated than plugging electrical plugs into the wall outlet. We don't call the electrical company and have a governance meeting when we want to plug in a new refrigerator into the wall system, into the electric utility system. The same is true of this Universal MPI. It ought to allow for that very rapid implementation with no tuning. Just plug in and begin resolving identities. Now let me talk about each one of those components just with one or two slides to give you a firm sense of what I'm talking about. And again, I'll start off with the database, since that's the cornerstone of the entire solution, having the universal reference database. And as I mentioned already, this reference database ought to cover the entire spectrum of the user population. So again, for us, that's the entire United States. But another important component, maybe critical component of the reference database, is that it has to be comprised of data outside of the patient domain. Within the patient domain, or any domain, errors tend to accumulate. They compound upon one another. One error propagates to the next system, that error propagates to the next system. So the proposal here with the Universal MPI is that identity information is taken from other very widespread data sources, things like the credit services or even telephone company service, since most people in the United States ultimately get a phone number, either at home, landline, or now increasingly cell phones, or they interact with the government and the legal system for permits and taxes and things like that. There are certain data sets that include everybody in the United States in one way or another, but are different enough such that errors that occur in one of them typically don't propagate to the other ones. And the idea is to accumulate billions of records from these diverse sources and build the compendium reference database. Now that sounds almost like rocket science and incredibly hard work, but it turns out lots of that data is commercially available, and if it's assembled together with the proper amount of real data science, people who really understand identity data and can apply all of their time every day, week in and week out, of perfecting those combinations of data, you really can build a reference database that has, over 300 million identities with dozens of years of historical data. And maybe most interestingly for everybody on the phone here is the fact that this data can be constantly updated. And maybe not constant, but on a weekly or a monthly basis, new identity information is flowing into this system through these data subscriptions, so that all of these identities are being kept up to date in advance of being needed at the hospital. The next time the patient comes to a hospital system, if indeed the identity is being linked off of this reference database presumably would have already captured the name change because of the marriage, or the address change because of the move, or even the gender change because of the gender change that might have happened. So that's another huge advantage of having built and providing to everybody a large-scale reference database. Now, with that reference database comes the question, well, okay, I've got the reference database. I feel intrinsically how I can see how it might help with matching, but this slide here kind of illustrates the point of how the matching works when you have a reference database versus when you don't. On the left-hand side of this diagram, or of this slide, you see traditional probabilistic matching. This is what takes place in your MPI today. Two identities represented up there by the green and the red Tinker Toy figures representing a different configuration of identity attributes or demographic attributes. With MPI technology and probabilistic matching that it uses, those two identities would be overlaid upon one another in the MPI, and if there was enough overlap and coincidence between the identity attributes that are presented, the MPI would declare them the same person. But if there's not enough overlap, as indicated by the animation that I just did, you would see that the two identities would not be considered the same person, even though they might very well be the same person, simply a name change and a address change. But if you look on the right-hand side with referential matching, those same two fairly diverse identities, identity A and identity B there, if you overlay them not against each other, as we did with the MPI, but instead you overlay them on top of the Universal Reference Database that has a much larger version of this person's identity, you can see that two very different identity fragments for the same person, even though they don't overlay on each other, they can overlay perfectly on the Universal Reference Database. And that, more than anything else, is the magic with having a Universal MPI database. It has an identity target for every individual that is big enough, rich enough, to match with almost any combination of identity that you typically have. And probably what's in the back of people's minds, and a very powerful thought, is that what this means is that you don't need to reconcile all of your identities, or you don't need to harmonize all of your identities in your different databases. They don't all have to be updated to the most current address, or to the most current name, or to scrub out all the nicknames. As long as the target database has all of those different combinations of data for Mark LaRoe or any other identity, you don't need to correct your data anymore in order to match it perfectly. It's an extraordinarily powerful concept, and it's a hard one for many of us to get our heads wrapped around because we spend so much of our careers cleansing data and trying to synchronize it and harmonize it. But in this model, you don't need to. And in fact, I'll skip through these slides or this detail a little bit quickly, but I want to emphasize with you that the four dominant powerful characteristics of this referential matching using identity databases or reference databases is that it really can see through sparse data like nothing else. You can look up identities with names and an address, or a name and a zip code if the name is unique enough, because for the first time ever, the reference database can tell you whether there was a Mark LaRoe that ever lived in Vienna, Virginia before. And if there was no other Mark LaRoe, then indeed the Mark LaRoe that we have here, Vienna, Virginia, without even a street address, very well maps to, or very assuredly maps to, the Mark LaRoe in the Universal MPI database. In the same way, it can see through errors like better than probabilistic matching, because it's not guessing about errors. In fact, it has all of the common errors of Mark LaRoe already in the Universal database because they've been registered through other means as being valid references to Mark LaRoe in the past. It can see through time because we've got a long history of time. It can see my older addresses, my newer addresses. It can see my previous names, previous nicknames. And then, as I've already mentioned, I won't belabor this much further, but probably the most powerful thing that this reference database with referential matching can do is it can do matching by exclusion. It can rule out all other possible conclusions because there's nobody else who comes close to matching the attributes that have been presented. It can actually test whether there are other people who this identity fragment could possibly be confused with. So powerful concepts. And in fact, we run with one of our clients in the federal government, we ran a very large test. In fact, we ran, and it was a very controlled test, but a good test because it used diverse databases, one of 3.1 million identities, one with 44 million identities. You can see that on the left here, where all 3.1 million should have been present in the 44 million. So there should have been a 100% overlap or match rate between the 3.1 and somebody in the 44 million. We ran this through state-of-the-art probabilistic matching systems, one of the best technologies in the market today, been in place for quite a long time, and it was able to conclusively match 70% of the identities. And these identities had all of the common errors at the typical rate that you see them happen. That same identity set sent through a uMPI or a referential matching system with a reference database achieved a 98% match rate with virtually no tuning. So a powerful confirmation of the process that I think we all would agree on the previous slide just seems intuitively obvious. This gives you the kind of the benchmark numbers to feel good about your intuition. And I guess the final thing to say about the uMPI idea is that if it is cloud-based, that makes it far simpler and faster to implement. So we're talking about implementing new data sources into the MPI in a matter of days or weeks and not months or years, and not requiring 3 or 4 technical people to do the proper tuning and going back and fixing things and making new balances between the weightings and the threshold values. All of this will be baked into the system so that it requires virtually no tuning. So, and then cloud-based, again, it's part of the API economy. So lots of things are now being served up via APIs. This is just one more thing. Identity resolution ought to be an API that makes it simple. Everybody can call it. It would have to obviously be HIPAA certified, high trust certified, or HIPAA compliant, high trust certified. And ultimately, too, by putting it in the cloud, it makes the system inherently scalable. Hundreds of millions of identities and sub-second response times. You know, if you run in the cloud environment, you can do dynamic scaling such that it never will run out of gas. It'll never run out of capacity, regardless how much it's used. And it's all of these things that are necessary in order to face this nimble environment, or this requirement for nimbleness that we're going to see going forward, as we have to bring on more and more systems into our MPI. Now, I'm sure a lot of you are thinking to yourselves, okay, technically I can see the basic concepts, but I'm having a hard time visualizing how this whole thing would work. And so we built this relatively simple slide which has some animations in it to describe, you know, how you would use a cloud-based universal MPI to do patient resolution and patient matching on your premise. So you can see over there in the left-hand corner 3 different buildings, but each one of them really represents a different system, maybe lab systems, an EHR system, and a pharmacy system, each of which has their own database of patient identities. And the problem is, okay, how do I harmonize all of its identities? Normally I would get an MPI or an eMPI to do that. With universal MPI, the process would be different. Here's how it would play out. The first thing that would happen is all of the identities from each of those systems would be mapped to their corresponding identity in the universal MPI. And that mapping would take place using this really precise referential matching that I just talked about. Once all of the identities were located within the universal MPI, once the associations were made, then there we go. Then those identities would be pulled out and basically would be assembled and ordered according to every reference identity to which the patient identity mapped. And in essence, what that would result in would be a virtual private MPI that exists in the cloud on behalf of the lab and the EHR system and the pharmacy system. Each of those systems would retain their own identities, but they would be organized through their linkage to the universal identities in the universal database. And that by itself is an extraordinarily powerful idea. If the identities in the universal database are organized, then simply by associating every one of the patients with them, they then self-organize and self-line up with no further data cleansing correction required. And then to finish off this story, if it weren't powerful enough, the fact that the universal MPI is being updated with millions of identity updates per month, so new names, new addresses, corrected SSNs, corrected birthdays, these things are constantly flowing into the universal MPI through large-scale data subscriptions. Those updates, those demographic updates, some of them will flow into identities that are mapped to real patients in the virtual private MPI, and those new attributes, those new characteristics of the patients automatically flow to the virtual private MPI, keeping it up to date or evergreen. A very powerful concept. And only possible with big data, and only possible with a large commitment to building that reference database and having the benefits of it flow down to the virtual MPI. Now, the other question I get, and I'm going a little bit faster, but I only have a few more slides, so hang with me here, everybody. The other question I get is that if I already have an MPI or an eMPI in place, and I'm not ready to convert it to this virtual private universal MPI, is there still some value I could get out of a universal MPI with my existing MPI doing most of the work? And the answer is yes, there is. There absolutely is. In fact, we all know that today with MPIs, when they can't make a match between two people, and two people here are represented by Mr. Light Blue and Mr. Dark Blue over there in the far left corner, lower left corner, what would typically happen is the MPI would send a task to data stewards so that they could then manually resolve whether those two people are the same person or not, using investigative techniques that human beings are better at than computers are. So, going on to the internet or LexisNexis or something to figure out whether that they're the same people or not. But again, using human judgment. Well, what I would propose, and what is happening in this model, with this universal MPI model, is that same task, if you will, that same ambiguity or that same unresolved identity task is Mr. Light Blue the same as Mr. Dark Blue. Instead of sending it to human beings, the data stewards, those same two identities could be sent to the universal MPI. Each of those identities could be mapped to their corresponding person in the reference database. And if they both match to the same, or map to the same person in the universal MPI database, then by definition they map to each other. And therefore you could use the universal MPI database as an augmentation to your data stewardship process. In essence, automating a good amount of the data stewardship. In fact, maybe even amplifying the volume, the capacity of your data stewards by the factor of 3. That's been our estimate. Actually, that's been our practice. That's been our observation. But not just amplifying our data stewards' capacity by automatically adjudicating the easier matches, but also doing it in a much faster time frame. So two major benefits of using the universal MPI, not to replace your MPI or the existing MPI, but to augment it or to make it operate better. A really powerful thought. And the only two final thoughts I'm going to leave you with is something that talks about the universal MPI not in solving the problem within the four walls of a hospital system or an insurance company or what have you, but the role that it might be able to play in providing identity resolution across enterprises. And the thought is this. If you have two enterprises, one here shown as a hospital and one shown as an HIE, but they could be any enterprises, quite frankly. If each one of those enterprises is using the universal reference database in order to create its virtual MPI in the cloud, then the sheer fact that both of those customers or both of those users of the universal MPI, because they are mapping their identities, their patient identities, to the same universal reference database, they by default are then mapping to each other. They don't even know it, but Mark Leroux in one of those databases, in the hospital systems database, is being mapped to Mark Leroux in the universal reference database, and then Mark Leroux spelled with a C, not with a K, in the HIE database is being mapped to Mark Leroux in the universal database. If the hospital system ever wanted to ask the HIE, do you have Mark Leroux, because both parties have mapped to the same identity within the universal database, they can instantly answer that question if they were cooperating. If they wanted to do so, they could instantly answer that question for each other because they would just reference the same universal identity as the common point of intersection. And this is the final slide. You can think of this same problem not between just two cooperating enterprises, two hospital systems or one pharmacy and another pharmacy, what have you, but you can think about it as if we have a large number of organizations all using the reference database to solve their identity problems within their four walls. Again, the same premise exists that they all then, by default, could, if they want to, begin resolving identities with each other with almost perfect precision because mapping simply between their identities and the universal database provides the conduit to map to anybody else doing the same thing. In essence, this becomes an identity resolution utility whereby every institution can talk to every other institution and be assured that they're referring to the same identity, the same patient. It's a very powerful thought. To sum things up for you here, let me finish just with the following slide, and this kind of wraps up the entire webinar. And I want to make sure I leave a little bit of time for questions and answers. That's why I went through the last two slides somewhat quickly. But look, the situation is this. MPIs have been really important components of our healthcare IT system, right? We couldn't get by without them. But we all realize that they're inherently limited. They basically reach the limits of their algorithms, and the data that's feeding them is not going to get demonstrably better going forward. In fact, what we know is the data that's going into these databases is going to get worse over time, or it's at least going to get more complicated, which makes the aggregate problem, the aggregate data, worse. And this is right at a time when the economic impact of not being able to match patients accurately is becoming very, very large. So this provides us with an untenable situation, which is the basic premise of this webcast, that something new has to be done. And something new is not something incrementally new, not a refinement or a new coefficient, but a new architecture. And the premise here is that new architecture is based upon big data. And it's based upon the assemblage of a universal MPI that everybody can use, that is assured to be very complete, very accurate, very extensive, so that we can all match patients within our four walls much, much better. And in so doing, as I showed on the last two slides, as so doing, it also opens the door for solving the national patient ID problem. It is the beginning of that solution where one institution can refer to a patient with another institution with absolute assuredness that it's the same person, but doing so without requiring the distribution of a national patient ID to every man, woman, and child in the country. So with that big thought, and hopefully with a little bit of inspiration from the previous slides, let me open the line for some questions and answers. Gus?
Thanks, Mark. Yeah, very informative. A lot of very promising information about the future. So look forward to seeing this play out. So yes, we do have a number of questions. We'll try to get through as many as possible. First question is, what about a universal patient ID? Industry organizations increasingly seem to be on board with a universal patient ID or UPID.
Yeah, well, okay, well, why don't I take that one, and I'll let Joaquin take the next one, whatever that might be. But, yeah, I mean, Gus, that question was a great question. It probably should have been asked just before one of my last couple of slides. My opinion and many people's opinions about a universal patient ID, a number and a card in some format or some number to be distributed to everybody in the country it's a very seductive idea. It's in fact, if we could do that, then there wouldn't be a patient identity problem. Maybe there'd be some fraud and some stealing of those things, but at least we know who was being the subject of the fraud. We know who the person is that we're talking about. But logistically speaking, and from a cost standpoint, it seems as though that's a bridge too far. You could take a look at what Medicare has to distribute new Medicare numbers to its 50 million beneficiary base, and to replace the Social Security numbers that have been used in the past. And even that is turning into a logistic nightmare for Medicare, and this is for people who've signed up for Medicare. So it's easy to whitewash over the logistical effort to distribute and maintain numbers for everybody in the country, but it's immense. And so, Gus, again, I would suggest to you that we need to look elsewhere for the solution to the problem, and this national, or this idea of a universal MPI, I believe, is that answer.
Mm-hmm. Very good. So next question, where does this fit into a healthcare technology stack?
Joaquin, you want to take that one?
Yeah, sure. And I think, Mark, you touched on this there towards the end. And this is kind of a critical question, is this idea of universal MPI needs to fit in a few different ways. So, we recognize that the IT landscape in different organizations varies a lot, and varies depending on the size of the organization. If you're a small provider, large provider, whether you're a payer, whether you have ACO, there's different technologies in all of these. So we think universal MPI, there's basically two answers to that. One, it needs to fit in where traditional MPIs fit today. So you need to be able to plug it right in there, right in between all the contributing data source systems It needs to support all the existing, standards, fixed PDQ standards, and all of these things to be easily adoptable. But then importantly, it also needs to be able to sit on top of the traditional stacks that are there. So it needs to be able to sit alongside an MPI that is tightly integrated to a large number of applications and improve the results of that significantly. So basically, we think it needs to fit in both of those spots where a traditional one would fit, and then augmenting the set of technologies, both the MPIs and the EMRs themselves, that you've got in your landscape today.
Next question, and I'm either for Joaquin or Mark. From Nicole Furlong, she asks, with the uMPI, I would be worried about the database being hacked. That would give a lot of data to the wrong hands. What type of security could we have in place to prevent that? Even today, we can only keep up with security as quick as those that are hacking us.
Yeah, no, that's a good point. It's a good question. The answer is there's no one answer to that. It's just, it's a matter of diligence, and we all know that, and that's almost a trite answer to the problem. But the way most of these things would operate is that there would be no accessibility to the universal database except through the API, and the API would be one-to-one tied with each subscriber institution to the API. So it's not as though people individually can log into anything within the system and try and hack into it. There's only one way in, and that would be through the API. That predominantly is the main line of defense for something like this. It's not a system intended for human access or any kind of access other than system access, for which there's a certificates, manually placed certificates at both ends of the communication connection.
Mm-hmm. This next one is for Joaquin. There are a whole lot of questions about persons that might not be in the reference database. Can you talk about that?
Yeah, for sure. I saw those coming in. There's, folks asked questions about, how about the medical tourists, people that are coming to the U.S. for healthcare, minors that wouldn't be in some of the reference sets that Mark talked about. And those are great questions, great points. And so the reference database, certainly would not be seeded with 100% of persons that you're going to deliver services to in healthcare, even if it had 95, 97% of adults in it. So kind of the first thing is the universal MPI concept needs to do everything that traditional MPIs do today. That's the starting point. And then it needs to do more. So on the doing more front, we actually think that the referential matching concept can be applied to other data sets, even data sets that aren't, part of this pre-populated idea. So we think you can make a lot of progress using parent-child relationships, for example, that you can derive from the universal reference, making use of next of kin guarantor data that you can obtain through ADP transactions that are very rarely used in matching with traditional approaches, even doing new things, collecting multiple birth indication data from providers. All of this can work alongside the actual universal reference data concept as part of the referential matching approach to give us a significant improvement on accuracy, even for those sets of data that might not be in the preceded portion of the reference.
So next question. How close are we to realizing a working nationwide universal reference database?
Well, maybe I'll answer that one. I mean, there are a number of companies that have been in the business of identity data, largely for marketing purposes, and we all know who those are. This is the Experians and the, you know who they are. They're the big data companies who've collected data through lots of different mechanisms. So it's not unheard of, and we all know it's not unheard of that large-scale nationwide databases exist. Nothing like this exists of the quality for healthcare, though. Nothing. Although I would argue, for those of you who are interested in finding out what Verato is doing in this area, you should certainly follow up with us. But the challenge has been to build something of healthcare quality, and you might have noticed that when I showed you what you would do to populate that kind of a quality database on a previous slide of mine that I presented, I did say that there is purchasable data from the credit agencies, not with your credit score, but simply with the identity information that comes in through every credit check that's done on each of us, or through our utility subscriptions, or through our interactions with the government and the legal systems. It's certainly possible, commercially possible, to assemble this kind of data from multiple sets that exist today. It just hasn't, up till very recently, hasn't been done.
Well, with that, we are running out of time, and I want to thank Mark LaRoe and Joaquin Bueno for a great presentation, a very important topic, and I'm glad to see, this vision. A number of people asked questions, and we will contact you. The staff of Verado will be in touch and to respond to you directly. So thanks, everyone, for joining us. I want to point out that as you leave, you'll be receiving a feedback form. We do ask that you complete it and let us know. We always want to make sure we're putting on the best educational content at the HIMSS Learning Center. And you will be receiving a link to the recording. It will be available within a couple of days, and you'll get an email. We encourage you to share it with your colleagues, and it will be available for you to continue to use. So thanks again to Verado for sponsoring this very informative presentation, and we hope you all have a wonderful day.